thing I think you guys know about an isosceles triangle, two sides congruent. We all agree on that? Two sides congruent. Well, here's the other fact I need you to realize today is yes, though two sides are congruent, but so are the angles across opposite those sides. Right? So if I know on a triangle's isosceles, I'm given the two sides that are congruent, like on your notes, AB and AC are congruent. The angles opposite them are congruent as well. So you have, this theorem lets us say that angle B is congruent to angle C. Okay, so that's what we can jot in there. That theorem lets us know that angle B is congruent to angle C. Right? So not getting this habit starting today. Yes, the sides are equal, but so are the angles. Okay, so are the angles. Oh, geez, and this is one thing I got to make sure we're clear on. Hey, it's not always the bottom two angles. It's not the bottom two. Watch, I made a new triangle up here. Is that still isosceles? Yep. So that also means the angles across opposite those sides. So that would mean this angle here is congruent to this angle here. I just don't want you to get in the habit that it's always the bottom two. That's not the case. It's always the ones opposite the sides. All good? And then we can also go in reverse. If you are given two angles that are opposite, or two angles that are congruent, excuse me. If you're given two angles that are congruent, you can say the sides are congruent. Okay? So if B is congruent to C, this theorem lets us say which two sides now are equal. BA is congruent to AC. And again, it's just not the left and the right sides. It just depends on where the congruent angles are. All right? Good? Everyone all right? And we're going to use that in a proof on Monday, those facts. But for today, we're just going to stick with the algebra. And before I get to the algebra, we need to go over some vocabulary. Okay? Because we got to talk to each other. I don't want to say, the congruent sides. They actually have a name. I don't want to say the non-congruent side. That actually has a name. So the angles between the angle between the congruent sides is called the blank. Anybody know? The angle between the congruent sides. So in my case, angle A. Anybody know what that's called? Begins with a V. Ends in vertex. Oh, good, guys, good. Yes, basically the non-congruent angle is called the vertex angle. Okay, that's called the vertex angle. And if we want to, so in this case, it would be angle A in my diagram. The congruent sides. Anybody know what the two sides are that are congruent called? Because I hate calling them congruent sides anymore. Come on. You got two of them. And you use them to walk.
Legs.
You guys are good picking up my clues. The legs, yes. Those are the two congruent sides. So let's start calling them legs, please. What about the unequal side, the black sheep of the group? Maybe some of you can relate. Too harsh? Sorry. Not sorry. Anybody want to guess the non-congruent side? I don't know what I could give you for a clue here. How about I just tell you? Base. It's called the base. And the two congruent angles are called here's your hint. What's the side in between them? What did we just call the side in between? The base. So these are the base angles. All right, base angles. Before we move on, one thing I do want to show you. This theorem here, that the congruent sides are across from the congruent angles, only works in a single triangle. a single triangle. Watch. That's our theorem, right, today? That's our theorem. Here's what I see a couple times, too. When kids see two triangles, watch, and I give them this, they think these angles are equal. No, that's not how this works. This theorem works for a single triangle only, not two different ones. All right? So can't do it. Everyone see what I'm talking about? This works because it's in a single triangle. The congruent sides are in a single triangle. It does not work here because the congruent sides are in two different ones. Please make sure you understand the difference. All good there? All right, because that's a common, oh, these two sides are equal, so hey, these two angles. No, they're not. No, they're not. They're not in the same triangle. The sides have to be in the same triangle. All right, let's go. I got a couple pieces of information here. I marked up my diagram for you. Angle R. Angle R would be equal to which other angle? That's not marked. That's not marked. I want you to find a new angle, please. Angle R would be equal to which angle in that diagram that is not currently marked? What was it? What would it be? UV. Yep. Angle UVR. Everyone see that? Take a look. I'm looking at this triangle here. I have two congruent sides in the same triangle, so that means the angles opposite are also congruent. See how that worked? All right, why? And I'm just going to get you guys set up for Monday when we do this in a proof. In a triangle, and yes, I do have to start this theorem out with in a triangle. It doesn't work for a quadrilateral, a pentagon, an octagon. This only works for in a triangle, congruent. What did I give you in this triangle? Sides or angles? The triangle we're working with right now. Did I give you sides or angles? So congruent sides are across from, how do you think I'm going to finish it? Congruent angles. And look, honestly, guys, I don't care if you flip-flop these congruent angles across from, that doesn't matter to me. All right, I'm not going to be that picky. But yes, I do have to start out with in a triangle. This is the only type of polygon that it works in. All right, what about RT? RT should be congruent to which other side? RT, RTN. RTN. Yeah, you're just making sure we're all on the same page here. Does everyone see the triangle we're working with? Why would that be true? What do I already know about this big triangle? Which angles are equal? Tim?
Angle R and angle S.
R and angle S. So you look across from R and S. Those sides are congruent. And it's got to be in this triangle here. So I look across from angle S. Everyone sees RT. I look across from angle R and I see TS. Yep. In a triangle, congruent angles are across from congruent sides. And again, that order I'm not even looking for. But that is the theorem I'm looking for, though. And then how about V-dubs here? VW. Sorry, I'll never do that again. I'm sorry. I just slipped out. VW and WS. Everyone see the triangle we're working with? I have two angles congruent, so the sides across are congruent. Yep. See, what was I given there? Congruent angles. Any questions? It's going to be a quick day. Quick day. You got two more in here. Of course. Anybody else? I maybe had like 2 people see that or no? Still 0. That's it. You had your moment. All right, you and your group, go ahead. I'll leave you to these 2 algebra ones. You're dealing with isosceles triangles. Don't forget what we learned today. The angles across are also congruent. Look at those directions on the homework. Okay, people are finishing up here. All right, let's look at this for number 1. This bottom triangle is isosceles. We're all good, which means the angles across are congruent. So if that's 55, the other angle across from the other congruent side must be 55. What'd you find for x then? 70 degrees, yep. And then hopefully you use that 70 because it was vertical with this angle. That's 70. And what do you know about the remaining 2 angles? They're also congruent because on the top one's isosceles. Whatever's across from the congruent sides are congruent angles. So that means I had 110 left, divided up evenly. Angle Y should have been, there we go, 55. We're all good? All right, 110, where'd you start out? 110, what's next to it?
70.
Okay, thank you, 70. That makes angle Y a little easier, right? Angle Y. I got 90 and 70. Or you could have did, hey, 110's exterior, it's equal to its remote interior, so Y had to been 20 degrees. Everyone's good? And then how'd you find angle X? We used the theorem today. What type of triangle is the big one here? That's what type of triangle? It's isosceles, right? It's got 2 sides. The legs are congruent. It's got 2 sides. So if that's the case, the angles opposite have to be equal. And the angles opposite are 70 and X, so X also has to be 70 degrees.
Could you also have done that the corner was 90, and then because it's split down the middle, Y is the other side is 20? And then
Well,
X?
yes, but I don't like just split down the middle. How do we know that, though?
Okay.
Right? And the answer, here's the, let's see, how could I figure out that it's actually 20 and 20 on each side mathematically? We already know that's 70. They got a right angle. That's true there. Oh, here you go. Ready? This is right exactly what we're doing, how I know these two angles are going to be congruent. Look at these two triangles. Everyone see the two separate triangles? They already have a pair of sides. Here's a reflexive side. Anybody know the reason, the method why those two triangles would be congruent? Why are these two triangles congruent? Something we talked about this unit pretty recently. This one and this one. What method shows they're congruent? You forget that quick, huh? Maisha?
Right triangles?
That's a method?
Like, well, it has something to do with it.
You got 5 methods, guys. 5. 5. Kayla?
Angle side.
Where's your other angle?
Oh.
Right? You have the right angle, and that's the only angle I have. Dean?
Side angle side?
You guys are killing me here. You're killing me. Is that angle in between these two sides?
Oh.
It's not side angle side. That right angle's not in there. Somebody just help me. The 3 of you, 4 of you. Go ahead. HL. HL. Remember that? We did that yesterday. It's a right triangle. HL. Good. So the two triangles are congruent. Oh boy, I'm even nervous to ask this. Okay, the two triangles are congruent by HL. What reason would tell me now those angles are equal after the triangles are equal? CPCTC. That's why the angles would be equal. The triangles are equal by HL. CPCTC says, yeah, those angles are equal now. Whew. All right. Hopefully we don't get too nervous next week when the proofs go up a couple levels. Oh boy, on the homework, 39. Be ready to factor. Don't give up. Okay, let's go. Go ahead, start it up. Got half the class still to go. Maybe we can get to that factoring problem and talk about it. And I am going